Welcome again to another edition or a lecture on distributed systems. It's a unit that explains how different systems are spread across. So the objective of our lecture today is to define what is a distributed system, the principles of distributed system, the characteristic of distributed system, examples of distributed systems, resource sharing and web challenges of distributed system, system models, and the architecture of distributed system. So what's a distributed system? A distributed system can be defined as a software system in which components are networked to communicate and coordinate their action by passing message. Remember, it is a system. When you talk about, we have different things that are working together or communicating through a coordinated action by passing messages. So what are the principle underlying distributed system, or what makes something to be called a distributed system? A distributed system is a collection of autonomous computers connected through a network, a distribution middleware, which enables computers to coordinate their activities, to share resources of the system so that users can perceive the system as a single integrated computing facility. Let me take you back. Autonomous computers, these can be said to be independent computers, or in a simple manner, we can say it's one computer. And then we have the second thing that is said to be a network. All these computers, which are different or maybe in a different location, they must be connected via a network. And there must be something called a distribution middleware. There must be a linkage between one environment to the other. Like an example of a middleware, this is an example, can be maybe an operating system which specifically works on the network, right? For a computer to connect to a network, you have to have drivers, or the network drivers, to be specific. Let's continue on the definition. So the middleware enables the computers to coordinate. So the middleware enables the coordination of all activities, and the user should perceive the system as a single unit, right? So these autonomous computers working together, at the end of the day, the user must perceive that system as a one unit. We don't want to have a scenario where someone is feeling that someone is pulling one web page from this website to another. We want this unit to people to perceive as a one, but at the back end we know they are not one. And the last thing, to have one common goal. So for anything to be called a distributed system, it must have all these characteristics. To just highlight, autonomous computers, middleware, it has to be networked, and it has to be perceived to be one unit. What is the opposite of a distributed system, or where did we start before we came to the idea of the distributed system? We had a centralized system. When you mean by a centralized system, it's commonly, let me put it as a standalone system. It's not autonomous, right? So the first characteristic of a centralized system, it's one component with non-autonomous part, so it's one. It is not connected to any. Component shared by users at all times. So components, they don't have any changes, are the same system. So it's central, all resources are accessible, no regulation, nothing, all resources are shared. Software runs in a single process. So an instruction is run per single process. And then we have a single point of control. So you have to only control from one place. So the point is a place. So in case it's a computer, you have to go physically to the location, control it. And then single point of failure. When you talk about a single point of failure, that means when the system fails, no one can access that. So once it fails, you don't have any fallback plan. So that's why we no longer study centralized system. We are now going to distributed system. So what are some of the characteristics of distributed system? The first one, we have the autonomous component. When you talk about multiple autonomous components here, they are separate, but they are multiple components. Remember that was the first principle that makes a distributed. It must be autonomous, but they should be multiple. They should be separated. The second characteristic, components are not shared by all users. And that brings an issue. You only access the components that involve you. So security issue should come in your mind. So distributed system, they have an issue about privacy and security, mostly privacy. So the second characteristic is the resources. Resources may not be accessible. What do you mean? You might not access maybe a server physically or a network physically, but you're able to get that resource. That's what we mean. Software runs in concurrent processes. Different processes run concurrently at the same time. So different software run concurrently using different processors. Right? The second characteristic, it's the fourth one. Multiple points of control. You can control this system from different sections. In case you have a server and it's in Nairobi, an example, it's hosted in Nairobi, and you have a mirror server hosted in France, you can use the server in Nairobi, and also it sends the information to the other server in the other location. So it has multiple points of control. We have multiple points of failure. In case one server fails, I'm just using a server loosely so that you understand. In case one server fails, another, you can be in a position to access the information from the other server because it has multiple points of failure. So that you can see the reason why we shifted from centralized, because in centralized, we only have a single point of failure. Once a server maybe fails, that's it. But in the distributed system, you're able to you have different point of failure. And these, I can just give you a loose example. An example, in case we discuss about Google servers. They have different servers. In Africa, we don't have any single Google server. So I think the closest one here, it's in Israel, and the other one is in Turkey. So in case you try accessing a resource maybe from a server, you won't see it physically, obviously. And the server in Turkey, which is a bit close, it's not working, it will redirect you to the next server. So it will keep on redirecting you to the next server till your client is satisfied. Remember, the most important thing you should remember that a distributed system, you should not see it as an autonomous. You should see, yeah, they are separated at the architecture level, but there should be one convergence place. So that's what we mean. Examples of distributed system and application. How do you apply distributed systems? The first one, and most familiar, is in the telecommunication network industry. An example is in the telephone networks and the cellular networks. Computer networks, such as the internet, and internet is an example of a distributed system. We have the wireless sensor networks, and also we have the routing algorithm. The routing algorithm in the router, where you understand when you're using dynamic IPs, once you try accessing, you are routed to another router, and that way it's how networking is done. So most routing algorithms are distributed systems. So we can continue. Network applications. Distributed system used in network application in the World Wide Web and peer-to-peer networks. Also in the gaming industry, distributed systems are used in online gaming. A good example is we are in 2020, we have the COVID crisis. You can see in the gaming industry, our Kenyan runners can virtualize how they are participating in the athletics. So they have the virtual reality, community online gaming. You can have a player here and your opponent is somewhere in another continent. We also have distributed databases, and that's an example of Google, which has different databases distributed all over the world. And then we have network file system that also uses the distributed system. The next area, that distributed system is used in in the parallel computation. That's in the scientific computing, cluster computing, and grand computing. That's where we apply distributed system. So what are some of the common characteristics of a distributed system? For you to be in a position to say that this looks to be like a distributed system, these are some of the characteristics. The first one is resource sharing. The ability to use the hardware and software or data anywhere in the system that makes a system to qualify to be a distributed system. And why? Because resource manager controls access, provides naming scheme, and control concurrency. How I can give you an example. I really love working with Google because it's one of the most successful companies. You can be in a position to access Google concurrently with your colleague or your fellow student seated next, and you won't have any crashing, or you won't be able to access because there's concurrency, and there's also controls. Your colleague won't be in a position to know what you're doing on your computer or your device. The next characteristic is openness. Openness is concerned with the extension and improvement of distributed system. So the next characteristic is concurrency. Concurrency can be said to be an example when you execute a process here, and on the other side you have a gamer. Let's use the gaming example. and your score is maybe 15. On the other side, your opponent should be in a position to see that your score is 15, not a different figure. So concurrency is very, very important in a system. Another thing is scalability. A distributed system should be scalable. What we mean by scalable is it should be in a position to accommodate more users, and respond still faster. When we talk about scalability, we don't mean that you increase the number of users and the usability reduces. We say that you increase the number of users and the speed remains the same. So in a distributed system should be scalable, and that brings a point of processors, the CPU. Whenever you think about a distributed system, you should think about faster processors because of the reason of the scalability increasing. And then the last thing is the fault tolerance. All systems are bound to fail. We don't live in an ideal world. So sometimes when a network fails, what happens? You don't only cast, but you have to plan yourself. So all or most distributed systems have fault tolerance. They can tolerate fault. And how do you do it? An example, you can have recovery. You can have recovery. Most software these days, they have an option of recovering information. Maybe you've mistakenly deleted the information. The redundancy option, this is the option where you duplicate your work in different maybe servers so that in case one fails, you're able to access. That's how you deal with the challenge about fault tolerance and many other. The next thing that is very, very key and very big in distributed system is transparency. Transparency should be perceived by users and application programmers as a whole, rather than a cooperating of different components. So different parts of the system should be transparent. What we mean, there are different components that are cooperating together to achieve a certain goal. We have different types of transparency. This is just a pictorial representation. We have the scalability, performance transparency, failure transparency, migration transparency, replication transparency, concurrency transparency, access transparency, and location transparency. Let's talk about this transparency, because without understanding this, it will be a bit difficult for you to understand why we decided to study distributed system and why we apply it. Transparency, that's access transparency. It enables local and remote information objects to be accessed using identical operation. Like an example, you have maybe a file system and your colleague is trying to access the same system. Yeah, you'll be able to access the same system transparently. So there is always access transparency. So you know who is accessing what, mostly in the file system operation in NFS. So for you to understand further about this transparency, because we won't take the whole time discussing about this transparency, you can check out on this file system operations. The location transparency, it enables information object to be accessed without knowledge of their location or the user knowing where you are. You can imagine in a world where anytime you're using a web browser, maybe the internet service provider knows where you are. So you have that option of enabling the ISP to know your location or not. So there's always that location transparency. And in case you have issues with the location transparency, mostly in the internet, because internet, we gave it as an example of a distributed system, we have an option of creating a virtual private network that will disable your users to not to see the location and to solve the issues about the location transparency. The other thing is concurrency transparency. This one is the most interesting one. It enables several processes to operate concurrently using shared information object without interference between them. And I've given an example of an automated teller machine network. You can imagine when you go to an ATM and you withdraw your money and you run to another ATM and you find your balance is still the same. That will bring some issues about the transparency. So our distributed system should be concurrently. In case you withdraw money in this ATM, the balance should reflect immediately. So that's why I decided to use the automated teller machine example. So the replication transparency, it enables multiple instances of information object to be used to increase reliability and performance without the knowledge of replicas by the users. I think that's it's straightforward. The user should know what is being done behind the scene. Because remember, distributed should be a one entity. And then another transparency is the migration. It allows movement of all information objects within a system without affecting the operation of the users or application programs. You can move different files without affecting what the users is currently doing. An example is when you're on your web browser and there is a new update. The web browser will notify you that there are new changes, but you need to upgrade it. So you have to maybe click on, maybe restart your machine later. So transparency, migration transparency is key. And also, the last one will be the scaling transparency. Scaling transparency is it's more like you want to expand. But according to the literature here, it allows the system and application to expand in scale without the change to the system structure or the application algorithm. You might expand your distributed system, but remember, it shouldn't alter the results. Right? And that's what I said about you might decide to expand, but remember, let the speed remain the same. That's makes your system scalable. So don't talk about your system is scalable, but when you add maybe 100,000 users, your system start dragging back. The foundation is a bit of a challenge. So let's continue to a little bit of the hardware concept of distributed system. That was just an overview, characteristic, and the introduction, but now we have to understand the concepts, the hardware concept, or the physical concept of the distributed system. I decided to pick two major things that decides how processes are done in a distributed system. So the first one was the multiprocessor. The multiprocessor, you can check the literature. A multiprocessor is a computer system which two or more central processing units share full access to the RAM, random access memory. Into brackets, these are volatile memory. So we are talking about processor. Anytime we're talking about a processor, something should come in your mind is the CPU. And then the CPU does what it processes, right? But it has to get access from the random access memory, which is the RAM. So they go hand in hand. So anytime you're discussing about the processor, you cannot discuss about the processors without discussing about the RAM. So what is the main objective of using a multiprocessor? The reason is to boost the system execution speed. Execution speed with other objectives being fault tolerance and application matching. So execution speed. I've always told you in this class that when you talk about execution, it's not killing, but you're just working on giving an instruction to a computer. So execution is giving an instruction, and that instruction must be processed. So when you have a multiprocessor, it enables your request or your instruction to go a bit faster, because every programmer or any computer user wants a faster computer every day. So the multiprocessor helps in increasing the speed and also reducing the chances of fault or application matching. Let me just make you think like a layman or someone who doesn't understand anything about the microprocessors. Anytime you talk about my computer has hanged, yes, it is an error caused by the processors and the RAM. There is a challenge that an instruction is a bit slow to be processed. So what do? You need to think about the processors. So the fault tolerance are a bit minimal. So there are two types of multiprocessors. We have the shared memory processor and the distributed memory multiprocessor. So for the shared memory multiprocessor, all the CPUs share the common memory. All the CPU share a common memory. So all the processors, the things that process the instruction, share the same memory. What we are talking, when we talk about this memory, is none other but the random access memory. So a common memory. So what's the difference of the other one? The distributed memory has its own private memory. And for the distributed scientists like us, we are focusing with the distributed memory multiprocessor. That's our core business. So this is how I try to represent a shared or a multiprocessor. So we have the shared memory and we have a CPU. All these, when you talk about the CPU, is not a computer. These are processors. So you need to think like a computer genius. So let's continue. So what's the application of a multiprocessor? The first application, I've just given two, it's as a uniprocessor such as single instruction, single data stream, SISD. The second application is as a multiprocessor such as single instruction, multiple data stream, SIMD, which is usually used for vector processing. What are the benefits of the multiprocessor? The first thing is enhanced performance. Multiple application can run concurrently. Multitasking inside an application is easier without the so-called hanging or the slow response of applications. Then hardware sharing among CPUs is it's much improved. And when you talk about hardware sharing, we're talking about sharing of printers and in most cases servers. So let's go to the next concept, which is called a multicomputer. Because we discussed about the multiprocessor, let's discuss about a multicomputer. A multi-computer, according to this narrative, is a computer system which multiple processors that are connected together to solve a problem. Take note, each processor has its own memory and it's accessible by that particular processor, and those processors can communicate with each other via an interconnected network. I knew that the narrative is too much, so much literature, but let me explain. So this is the interconnection, this is the memory, this is the processor. So with this interconnection, they can share the same processor, so making it a bit good. So let's proceed. A multi-computer can be used for distributed computing. It is cost effective and easy to build compared to a multiprocessor. Remember, we are just sharing memory and processes. So it is cost effective and easier to build. So the multi-computer is capable of passing between the processors, and it is possible to divide the task between the processors to complete the task. So you can see this is the best solution for our distributed system scenario. So we've known we have a multiprocessor and we have a multi-computer, and we've said a multi-computer is the most ideal for a distributed system. So what are the differences between a multiprocessor and a multi-computer? A multiprocessor is a system with two or more central processing units that is capable of performing multiple tasks, whereas a multi-computer is a system with multiple processors that are attached via interconnection network to perform a computation task. Remember, when you talk about a task, in a distributed system, we are talking about a specific task, right? All the distributed systems are working together to achieve a certain goal. So the multi-computer is ideal for the computation task we are discussing here. A multiprocessor, the other difference, a multiprocessor system is a single computer that operates with multiple CPUs. Remember, CPU is a processor, as where multi-computer is a cluster of many computers that operate with a singular computer. So there are a number of computers. Those are some of the differences. So the construction of multiple is much easier and cost-effective than a multiprocessor, and that's why we have said it's ideal for a distributed system. In multiprocessor system, program tends to be easier as compared to the multi-computer, so program tends to be more difficult, right? In the last difference is that the multiprocessor supports parallel computing. Computer supports distributed computing. So already I've told you about the distributed computing, but for your assignment and research, because you're scholars, you're going to work on the parallel computing and see the application. That's the assignment you're going to do before the next class. So for the private shared and potentially shared memory, what are some of the differences? So a private memory is a memory used solely by selected processes. When you talk about processes, I think you understand it's an instruction. It is an instruction. So is memory used solely by a specific process? Shared memory is used by at least other processes in addition to the selected processes. For you to be in a position to understand this, you can click on the, at your free time, you can click on your computers go to the taskbar, and then you click on the processes, and you see how shared memory is being utilized in percentage form in your computer. And then that also is, you'll be in a position to understand about how shared memory and the private memory works. Something to note is when you're looking for memory leaks in a system, the private memory is usually more likely to be the concern. So here, in case there are any memory leaks, the private memory might be the problem. So we have the other thing that we need to discuss. It's about the bus-based multiprocessor, which consists of number of CPUs all connected to a common bus. Remember, it's a bus is they're just some electrical elements found in a motherboard that are used to move information from point one to another point. So when you hear about bus, it's about passing information alongside with the memory module. So remember, when you're talking about a bus, you're talking about transportation between the processor, which is the CPU, and the memory, the RAM, the memory. So this memory we are talking, in this multiprocessor business, we'll be discussing about RAM only. So don't think about any other memory, and maybe registers in some extreme cases. So the switch-based memory is divided into the modules and are connected to the CPU with the switch. Each CPU and each memory has a connection coming out of it. We are going to see in these, you can see, these are shared memory. You can see the processors. This is the bus, and this is the memory. I told you this is more like the physical bus that you travel you travel in the village with. So we have the memory and we have the processors. This is the bus. So in this is in a bus-based, in a shared, this is how the arrangement is. In a private memory, you can see you have the processor, memory, processor, and then a bus, and now you go to this processor. And vice versa. You can see on the switch-based, we have the memory, an interconnection here, and then we have, on the other side, we have the processor, all these are CPUs. And then in a private memory, this is how it works. So I think I trained my level best for you to understand about this physicality. But for you to be in a position to understand, you need to practice and understand the difference between shared memory, private memory, bus-based memory, switch-based, and that one you'll be home when it comes to distributed system. That's on the hardware bit. So in case it's a score, you are halfway there. So let's continue. The software concept of a distributed system. This one is very straightforward. The first one, when you talk about the first one is the operating system. These non-physical things. These are non-physical things. A network operating system is an operating system that manages network resources, especially an operating system that includes special function for connecting computers and devices in a local area network. I can give you an example. We have in most cases, we have Linux for the open source, and then we have Microsoft servers with the directory settings. That's an example of an operating system. The other one is a middleware. Is a software that provides a common service and capabilities to application outside of what offered by the operating system. A very simple system for you to understand an operating system. Once you format your computer, or when you remove the operating system and format everything, even everything, the BIOS and everything, and then you reinstall your operating system. Mostly when you use Windows 7, I'm not sure whether it's still supported. Sometimes you might try playing a music Your speakers are intact, the physical bits are intact, but there's something that is missing. And when you try to troubleshoot, something will pop up. Include the drivers. A driver is an example of a middleware. In case it's a network, we have the NIC network and all that. So a middleware, it's a link between maybe, let me just put it, a hardware and the software bit of a computer. It is more like, to loosely put it, it's more like how we say it here. It's a broker, right? Yes, I think you understand that. So let's continue. We have systems and the description, the DOS. Title coupled with the operating system for multiprocessor and homogeneous multi-computers. The main goal is to hide and manage hardware resources. Those you know, the network operating system loosely coupled with the operating system for heterogeneous computers and multi-computers, that's into brackets LAN. Take note, we've talked about the servers and the Linux operating system. We have other operating systems we won't mention here. Other local, the main goal is to offer local services to remote clients. Remember, that's what you're talking about, a network server. A middleware, it's an additional layer at top of the NOS, network operating system, implementing general purpose services to provide distribution transparency. So you need to separate these, and these, and that you can be tested, and you need to do such a matrix so that you're able to explain it in a better way. So let's continue. Distributed operating system. Some of the characteristics of these operating system we are talking. The operating system on each computer knows about the other computer. Remember, for privacy, you have to know the other computer, or it has to request to know about you. The operating system on the different generally is the same. It has to know about your computer. The services are general, transparent, and distributed across the computer. When we said about transparency, this is what now is applicable. You can see we have machine A, machine B, and C. We have the distributed application. When you talk about application, we're talking about softwares that are doing specific tasks, right? Let's move on. Okay, a specific task like working on a specific task, right? The next thing is a distributed operating system. That's more like a server. And then we have kernel, and then we have the network. All these we'll be discussing on our next lesson, so don't be scared when you see a new one, because I'm sure most of you haven't seen these since they joined maybe this class. So this is another example of a network operating system, some of the characteristics. Each computer has its own operating system with the network facilities. Computers work independently. They may even have different operating systems. Services are tied to an individual node, like the file transfer protocol, telnet, the WW, the world area, the World Wide Web, right? So on these, machine A, machine B, and machine C, let me just go back. In an operating system, remember, we're in a distributed network environment. Let's assume you have two clients. One client might be using a different operating system in the institution, and you have a different operating system and protocols in your own system. So in the network, you have to know that you have different users, right? And they have different choices. So they have different operating system, and they have their own protocols that they use. So they work independently. You don't need to control them. So you can see we have distributed applications, obvious, the network operating systems, services, and we have the kernel. All right, and then we can see the architecture of the middleware. You can see the OS on each computer need to know about the other computers. The OS on different need to generally be the same. Services are generally transparently distributed across the computer. So you can see we have distributed application. Then in between here, you have our, we loosely call it broker, which is the middleware. When you understand it, it stands between the application and the network operating system. That will be easier for you. So that's how it is. Yeah, let's move on. Those are some of the things. Then we have distributed. In every good thing, we have our own challenges. Distributed system has the following significant and consequences. The first one is concurrency. In a network of computers, concurrent program is the norm. It's the way of life. Concurrency is the way. Consistency is the way. It would be very bad when I gave the example of an automated teller machine. When you withdraw some cash and you go to another ATM, it gives you a different balance. That would be an issue. So distributed system concurrency is a way of life. No global clock. There comes another challenge. When programs need to cooperate, they coordinate their action by exchanging messages. And that brings our challenge. No global time. In East African time, now it's about, let's assume it's 12 a.m. But somewhere else, maybe where you've hosted your product or your server has another time. So which time will you use? Something to think of. Challenges of or consequences of distributed system. We don't have a single global clock. Independent failures. All computer systems can fail, and it is the responsibility of system designers to plan for the consequences of possible failures. Remember, the significant and the consequences are always mitigated. We try to mitigate and work together. And on that matter, in the next class, we will be talking about the time and the global states, coordination, and the agreement of distributed system. We'll be discussing about how do you tackle about issues about the global clock and agreements. So with that, thank you very much. See you in the next class.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.